Hello everyone. Beauty is rather a light that plays over the symmetry of things than the symmetry itself. As the quote say, we UG students of Sita Lakshmi Ramaswamy College, we are going to say about an interesting and amazing things that involve in a symmetry arrangements in nature. First of all, what is a symmetry? Symmetry is nothing but the structure that allows an object to divide it into an equal size and shape. The property of symmetry depends upon the three main characteristics that are size, shape and functionality. These exceptional cases we are such as if a functionality is symmetrical, size and shapes are asymmetrical. Example, amoeba. It is a well-known creature we know. It is an irregular in shape and size. But when it will be cut into an equal halves or an equals into a single cell, its function is similar. Then, and on the other hand, if size and shapes are asymmetrical, functionality is asymmetrical. Example, human body. When the human body is cut into an equal halves, we see that the outer organs are symmetrical like ears, eyes, legs, nose, etc. But when we examine interiorly, we can say it is an asymmetrical.
This point arises to a very interesting theory named symmetry breaking, in which infinitesimally small fluctuations acting on a system crossing a critical point decide the system's fate by determining which branch of bifurcation is taken. To an outside observer unaware of the fluctuations, the choice will appear arbitrary. The types of symmetry breaking is explicit breaking and spontaneous breaking. Explicit breaking is a breaking of symmetry by terms in its defining equations of motion, mostly Lagrangian or Hamiltonian, do not respect the symmetry. But the opposite of explicit breaking is spontaneous breaking. Spontaneous breaking is a spontaneous process of symmetry breaking by which a physical system in a symmetrical state ends up in an asymmetric state. It obeys the equations of motion, but at the lowest energy vacuum solutions do not exhibit the same symmetry.
The most mysterious creation of the nature is the brain. The brain is a fascinating example of symmetry. Till now, the functionalities of the brain remain as a miracle. The left and right hemispheres of the brain is a mirror image of each other. As before said, they are symmetric by its appearance, but they are asymmetric by its functionality. This mystery is termed as lateralization of the brain, according to which the left hemisphere of the brain controls the right side of the body and vice versa. This is due to decussation, that is crossing of nerves. Weirdly, the olfactory system is not reversed, it is the smell. The visual system is only partially reversed. This is totally weird, right? The question arises here is why, and why? Investigators couldn't explain why this reversal is inconsistent. While the vertebrates decussate, the invertebrates like jellyfish, worm, crab, etc. they do not decussate. The fact behind this is that in the invertebrates, the nervous system starts from the brain and runs along its animal belly, and the digestive system is above. But in the case of vertebrates, this is totally different. As determined, the brain, the intellect of living kind, is a ridiculous symmetry.
The next branch of physics in which we are going to explore symmetry is crystallography. Let's see some interesting examples. Firstly, quasicrystals, the materials which shouldn't exist. Quasicrystals possess 5-4 rotational symmetry, which is forbidden in conventional crystallography. When it is rotated by 72 degrees, their appearance remains the same, thus proving its symmetry. There are also 2-fold rotational symmetry passing through the edges and 3-fold rotational symmetry passing through its vertices. This is called icosahedral symmetry. The next example is liquid crystals, which are found in most carbon compounds. Smectic liquid crystals have broken translational symmetry in only one direction, and nematic liquid crystals break rotational symmetry alone. Symmetry considerations have become the extremely powerful and useful tool for theoretical foundation in physics laws. Thanks a lot for providing this wonderful opportunity to explore the symmetry arrangements in nature.